Hello everyone, welcome you all. So in this video we are going to see about units and dimension for ECET examination. Okay, if I consider the weightage of this chapter in the ECET is 2 marks. So if you pay little bit attention over this unit, definitely you are going to score 2 marks. Okay, so in this video what we are going to see, first we will learn the concept and some fundamental about units and dimensions. Later on we are going to solve the previous 5-year questions for the units and dimensions. Okay, now let's see the basic. What is units here? What is unit? Unit is nothing but the standard of measurement. Okay, the standard of measurement is known as units. So we have 7 fundamental units are there. What are that? Length, mass, time, temperature, electric current, luminous intensity, amount of substance. These are the 7 fundamental units are there. So we will see their units, SI units, and we will see the symbolic representation for the dimensional formula. Length is nothing but the distance. The SI unit for the length is meter. In the dimension formula we represent length as capital L. Okay, here mass is there. Mass, the SI unit is kilogram, and the dimension formula we represent mass as capital M. And for time, the SI unit is seconds, and we will represent with capital T. Temperature here is measured. The SI unit for the temperature is Kelvin. The dimension formula we use theta, or somewhat we use capital K. And current here, the SI unit for the current is ampere. Okay, now for the current is represent with capital A. Luminous intensity, candela, and we represent symbol is CD. Amount of substance is mole, and represented by MOL. Okay, these are the most important here is this 4. Okay, these 4 are basically more we use this MLTK concept. Okay, what we'll do in some question, they will represent current, luminous intensity, amount of substance, temperature with some different letter. They will already give you in the question. Based on that letter only we have to give the symbol for the dimension formula. Okay, most we will use MLT theta. Okay, this 4. Now what we see some basic unit for the dimensions. We start with the velocity. So velocity, we will see here formula and units and dimensions. So first here is velocity. So what is velocity? Velocity is nothing but rate of change of displacement. So I can write displacement by time. So this is the formula for velocity. What is velocity? Displacement by time. So now I want to give the units for the for the velocity. Displacement is nothing but length, and length is measured in meter. So this meter M, this division symbol, and time is measured in SI unit for the time is seconds. So seconds. So meter per second is the unit for the velocity. So now come for the dimension formula. Displacement is nothing but the length we will represent with capital L, this division symbol, and time we will represent time with capital T. So I can write here m0, there is no mass, L1 t to the power of -1. I have taken t in the numerator. So this is about the velocity. Now let's take acceleration. Now let's consider the acceleration. What is acceleration? Acceleration is nothing but rate of change of velocity. So I can write velocity by time. Okay, so now you can break again velocity as displacement by time. Again you can write here displacement by time and this time. Okay, try to, here trick is there. You have given any units, try to break down the unit into our 7 fundamental units. Try to break down here displacement by time. Okay, velocity, again you can break velocity to displacement by time. So then only you can easily write the units and the dimension formula. Okay, so here velocity already we have written meter per second, you can write direct also, or you can see here displacement. Again displacement is nothing but the length is measured in meter. this division, t here time is measured in seconds, into this time also second, so nothing but meter per second square. So the meter per second square is the unit for the acceleration. If I want to write the dimension formula, how can I write? D is nothing but the distance is capital L divided by t here capital T into capital T. So I can write here m0, there is no mass, L1 t ki power of minus 2 if I take t in the numerator. So this is the dimension formula for acceleration. So now let us take what? Force. If you take force, what is force? From Newton's second law of motion, F is equals to ma, where m here is mass, a is acceleration. So here mass, now I am going to write the units for the force. Mass is nothing but kilogram, we measure in kilogram, here into is there, into acceleration. Again you can break acceleration into velocity by time, again you can break velocity and displacement by time. So your wish, now I am directly right here, already we have written the unit for the acceleration, so from here I will write what is acceleration here, meter, this division meter per second square. Okay, now kg into meter per second square is nothing but 1 Newton. So the unit for the force is Newton, and remember one thing, 1 Newton is equals to 1 kg into meter per second square. Now if I want to write the dimension formula for force, how can I write? Here m we will represent with capital M into acceleration here m0 is there, leave, L1 t ki power of minus 2. So I can write here m1 L1 t ki power of minus 2 is the dimension formula for force. Now let's move on. What we see, take energy. Any energy you can take, kinetic energy, potential energy, heat energy, any energy, and all energy will have same units and same dimension formula. Okay, for example, we consider kinetic energy. What is the formula for kinetic energy? Half mv square. Half here is a number, leave it. M here is mass, and mass is measured in what? Kilogram, into here velocity square is there, the unit for the velocity is meter per second, and square is there, so I can write here meter square per second square, because velocity is meter per second and square is there, meter square per second square. Now this kg into meter square per second square is nothing but joule. So the unit for the energy is joule. 1 joule is equals to kg into meter square per second square. So if I want to write the dimension formula, how can I write here? M here mass is represented by capital M into, and velocity is there and velocity square is there. So nothing but this, I will write L1 t ki power of minus 1 whole square. So I can write here m1 L ki power of 2 t ki power of minus 2. So this is the formula for dimension formula for energy. So what I can take in another, if I take power, what is power? Power is nothing but energy by time or work by time. So power is nothing but work by time. So now what is work here? Work is nothing but energy. Already we have discussed about energy. So what is the unit for the energy is joule, and this division symbol is there, and time, the time is measured in seconds. So joule per second is known as watt. Okay, so 1 watt is equals to 1 joule per second. So the unit for the power is watt, and 1 watt is equals to joule per second. If I want to write the dimension formula, what I can write? Work is already we have written this m1 L2 t ki power of minus 2 divided by time is t. If I take t in the numerator, m1 L ki power of 2 t ki power of minus 3. So this is about the dimension formula for power. So if I write something, now let us consider what? Pressure, for an example. If I write pressure, so what is the formula for pressure? Pressure is nothing but force by area. So now what is the units? We have to write the units for the pressure. Force is there, force already we have discussed. For the unit for the force here is Newton per area. What is area? If I consider rectangle, length into breadth. Okay, so length is measured in meter and breadth also measured in meter. So meter into meter square. So now for example, also if you consider square also, the area for the square is side into side. Side is also measured in meter into meter, again meter square is there. If you consider this circle, area for the circle is pi r square. R is the radius, again radius is measured in meters. Radius square means meter square, nothing but meter square. So 1 Newton per meter square is known as Pascal. Pascal. So I am showing some basic concept regarding the units. Okay, force is measured in Newton, and what does 1 Newton, 1 joule, 1 watt represent? We have to know all this also. Okay, now 1 Pascal, what that 1 Pascal means? 1 Pascal is nothing but Newton per meter square. Okay, here the pressure units are Pascal. Okay, Newton per meter square is known as Pascal. Now if want to write the dimension formula, how can I write force? What is force here? Already we have written m1 L1 t to the power of minus 2 divided by area is meter square. Meter means L square. This one cancel out. What I remain m1. If I take L numerator, L minus 1 t to the power of minus 2. So in this way you can write the dimensional and unit for any units if you know the formula, or units. If from these two, if you know any one, you can write the dimension formula. Okay, I think you got the idea how you can write the dimension formula for the quantities. Now what we will do, we will solve some previous year question. Now look at this question, the dimensional formula for kinetic energy. This was question asked in TS 2020 and 2022 in AP 15 also. Already we have discussed about this kinetic energy. So now I will show one more time. So now kinetic energy, what is the formula for kinetic energy here? Half into m into v square, half mv square. Leave the half here, it is the number. Now m here, first I will try break the quantity into our 7 fundamental quantities. Okay, here mass is there, nothing but mass. Okay, velocity is nothing but, if you know the dimensional formula for velocity, directly you can write here. If you don't know the dimensional formula for velocity, try to write down its fundamental, try to break down velocity into also fundamental quantity. For example, displacement by time, displacement by time, and this whole square is there. So mass is nothing but, if we represent in dimension formula for m, capital M, into displacement is nothing but length, capital L, divided by here time is there, and whole square is there. So I can write here m1 L2 t to the power of minus 2, m1 L1 t to the power of minus 2. Option B here is the correct for this problem. So let's move to next question. Now look at this question. This was question asked in 2019. So what is the dimensional formula for gravitational constant? So what is gravitational constant here? If I write the equation, the force of Newton's law of attraction, force equals to G m1 m2 divided by d square, distance between them. Okay, the force of attraction is directly proportional to product of their mass and inversely proportional to square root of the distance between them. Here G is the gravitational constant. Okay, if I form the equation in terms of G, what I get, if d is outside, G is equals to f d square divided by m1 m2. Here m1 m2 are the mass and d is nothing but the distance between the two bodies. So G equals to, again here f is force, what is the dimensional formula for force? Nothing but m1 L1 t to the power of minus 2 into d square. D is the distance is measured in meters and we represent L, square is there, so L square divided by m here mass, capital M, and this also capital M. So this m gets cancelled out. If I take G in the m, that side will become m in minus 1, this will be L power of 3 and t power of minus 2. So in the if I arrange in the order, option T3 L3 t to the power of minus 2 m to the power of minus 1. So here option B is the option 1 is the correct answer. Okay, option A is the correct for our given question. If I talk about the units here, if you see the units, if you want to see the units here, what is here, what will come? G equal to, here force is nothing but Newton, okay, into d is nothing but distance, meter square divided by, now here kg into kg, here kg square. So this is Newton per Newton into meter per kg square is the units for the gravitational constant. Okay, so now let's now look at this question. Force F is given by F is equals to AT plus BT square, where T is time, the dimensional for A and B are. So this is the question based on principle of homogeneity. Okay, so now this was question asked in 2027. I will explain you can give any equation they can ask, and they will ask the dimension formula for this a, b, anything you can ask. I will show you the simple way how you can find this type of question. So this is the question of principle of homogeneity. What does it say? Means the units on the both the sides of equations are same. What does that means? Means for example, I will show you. Given here f is equals to at plus bt square. So look at that. Here addition is there, means what, these two quantities are added. Okay, these two quantities are added only one condition, because both the units, both the quantity have same units, then only they can add it. Okay, for example, if I have 5 kg of sugar, 1 kg of salt, the customer asks me how many kg you are holding in your bag, so I can ask, I will add both and I give the answer. Why? Because both have same units. If they both have same unit, then only it can be added. And here saying equal to sign is there. Equal to sign means both LHS and RHS will have same units. So what does you understand from this equation is, whatever the units of force is there, this quantity, this also has the same units, and similarly this also has same unit with the force, because equal to sign is there. Okay, so now I can write from here f is equals to at. Both the dimension formula, if I write the written in brackets, for example, the dimension formula for force is also same as the dimension formula for at. One condition. Again similarly, the dimension formula for force is also equals to dimension formula for bt square, and as well as the units, then only they are added or they are equal. So now if what is the dimension for formula for force, we know m1 L1 t to the power of minus 2, which is equal to, here a is given, we have to find the a, and t already mentioned here is t is time, so time we can write as t. So if I take t here, what will come? A equals to ml t to the power of minus 2 divided by t, so it will go up ml t to the power of minus 3. So a here is ml t to the power of minus 3. So both are options, a and c will have same. So let's see, take part here, f here again ml t to the power of minus 2, b, t here is time, t square, so what it be, ml t to the power of minus 2 divided by t square, so it will be mt t to the power of minus 4. So which option, a, is the correct for this question. So now I think you got the idea how to write the dimension formula for the quantities, and you have also seen how you can find the dimension for unknown parameters if from using the principle of homogeneity. Okay, take the book and try to solve some previous year question also, then you will get the idea how you can write dimensional formula and units. Okay, in this video we have completed. Thank you.